This is our second practice problem where we utilize selection coefficients to calculate future allele frequencies. In this problem, I ask you for the change in the dominant allele frequency. Change in the dominant allele frequency is our delta P equation. So it's delta P equals S times P times Q squared divided by 1 minus SQ squared. So to calculate our delta P, we have to know S, P, and Q. S is typically given in the problem. In our problem, I tell you that a pollution event has occurred and that the pollution in the pond prevents reproduction by our small-bodied individuals. This means that all of our small-bodied individuals are unable to reproduce. This means that our selection coefficient is effectively lethal for that phenotype. If they can't reproduce, it's the same as killing them all off. So knowing that this phenotype is completely lethal, we know our selection coefficient must then be 1.0. So selection coefficient, we know. We now have to calculate P and Q. P and Q is calculated just like we've done in the past. So our observations of our genotypes are as follows. I will use big L and little l to represent the alleles. So in this population, we have 250 homozygous large individuals. We have 500 heterozygotes, and we have 250 homozygous recessive individuals. This gives us a total population size of 1,000. With this information, I can calculate our allele frequency. Big L is equal to P. That's 2 times the number of homozygous dominant individuals plus the number of heterozygotes divided by 2 times our population size. This gives me 1,000 divided by 2,000, or an allele frequency of 0.5. I'll repeat this with our recessive allele frequency, or Q. 2 times 250 plus 500 divided by 2 times our population size. I get 1,000 divided by 2,000, which is equal to 0.5. We now know S, we know P, and we know Q, so calculating our change in allele frequency is as simple as plugging and chugging. S is 1.0 times our P, which is 0.5, times our Q squared, which is 0.5 squared, divided by 1 minus S, or 1.0 times 0.5 squared. Delta P simplifies to 0.125 divided by 0.75. Delta P is thus equal to 0.167. This means that after selection, our new allele frequency will be 0.167 units higher than our observed allele frequency.